So in this video we will see some points on continuity or the continuous functions. Okay, so if I consider two functions f of x and g of x, and if they are continuous, then I can say f of x plus g of x, f of x minus g of x, f of x into g of x, and f of x divided by g of x are continuous, provided that, okay, g of c means at a point, if I consider g of c, it should not be equal to 0, because we have studied this in the rational function. So polynomial divided by polynomial is nothing but it is a rational function, and I have said you like what happens if g of c becomes 0. So if it is of the form 0 by 0, we have a whole, or if it is of the form constant divided by 0, we will be having an asymptote there. Okay, so second point we can see here is like, you know, sin x, this is a continuous function. In one of my videos I have proved it. Okay, so cos x, this is also a continuous function. With the same procedure of solving sin x, we can solve this cos x, and you can try it. Okay, tan x, it is also continuous, but at x is equal to 2n plus 1 pi by 2, it is not continuous. Why? Because tan x is defined as sin x by cos x. What happens if cos x is equal to 0? Okay, this is the same condition, right? So cos x becomes 0 when x is equal to 2n plus 1 pi by 2. So it is continuous everywhere except this point. Next, we can consider the power functions. Power functions nothing but the power x powers. Okay, like x square, x cube, y z. These are all are continuous functions. Okay, because this is a polynomial function, and polynomial function will be a continuous one. Okay, if I consider like 1 by x, 1 by x square, 1 by x cube, okay, these are also continuous, but at x is equal to 0, this will not be continuous. So continuous everywhere except x is equal to 0. This becomes of the form 1 by 0. Okay, this is the form, okay, where asymptote starts to exist. Okay, so this is not continuous at x is equal to 0. Next, if you consider square root of x, like cube root of x, so x to the power of 1 by 2, x to the power of 1 by 3, something like that. Okay, it will be continuous everywhere. Okay, but remember, x should be greater than 0. It's continuous everywhere, but x is greater than 0. Next, you have exponential functions. Okay, exponential functions. So if I consider something like 3 to the power of x, 7 to the power of x, 2 to the power of x, something like that, a constant with power x, okay, and e to the power of x, e to the power of kx, I will consider in general. These are also continuous functions, because if I consider, okay, at some point c, what happens, it will be e to the power of kc. So if I consider limit x approaching c, this becomes e to the power of kc. Both are equal, so the condition is satisfied here. So I can say exponential function will be continuous. Next comes logarithmic function. Okay, logarithmic function, it will be defined for positive x, right? So it will be continuous there, x greater than 0. So log x, that is base 10. Okay, then you can have something like 1 by 3x. Okay, everything that logarithmic functions for x greater than 0, it will be defined. Okay, they will be continuous functions. And in my previous video, I have explained you about the polynomial functions. So these are the some of the extra points that you can remember in this chapter, continuity.